What if I told you that there is a computer so strong that it can solve issues in minutes that would take other computers billions of years? Introducing Google's Willow chip, a quantum leap that is defying reality itself. You'll learn how this technology may even reveal the mysteries of parallel worlds at the end of this film. So stay tuned, a revolutionary breakthrough. Imagine a computer that is so sophisticated that it compels researchers to reconsider reality itself. That is precisely what the Willow chip from Google has accomplished. Not only did it break previous records, it completely destroyed them. Willow took less than 5 minutes to solve a problem that would have taken 10 septillion years for the world's most powerful supercomputers to finish. The twist is that some scientists think this quantum wonder may truly function across parallel universes, carrying out computations in several realities at once. We'll look at what Willow actually accomplished, why the multiverse is now being discussed, and why some academics are still skeptical in this video. The quantum leap, what makes Willow special? Google's Willow chip is a quantum processor with 105 qubits. But why does that matter? Let's break it down. In classical computers, information is processed using bits, which are represented as zeros and ones. But quantum computers operate differently. They use qubits, which are powered by two revolutionary principles of quantum mechanics: superposition and entanglement. Here's the exciting part. Superposition allows qubits to exist as both 0 and 1 at the same time. This means they can process a vast number of possibilities simultaneously. And then there's entanglement, a mind-blowing phenomenon where qubits become connected so that changing the state of one qubit instantly affects the others, no matter the distance between them. Together, these principles allow quantum computers to analyze problems in ways that traditional computers simply cannot. And that's where the Willow chip takes center stage. With its 105 qubits, it represents a significant leap forward, pushing the boundaries of what quantum computing can achieve. This level of performance opens the door to solving problems in fields like cryptography, materials science, and even drug discovery. Problems that would take classical computers millennia to tackle. Google's Willow chip isn't just a processor. It's a glimpse into the future of computation, where the impossible becomes possible. Breaking barriers. Willow's record-shattering achievement. Imagine this, a problem so complex it's called the random distribution benchmark. It requires generating outputs from incredibly intricate and interrelated quantum patterns. Traditional computers? They wouldn't even get close. In fact, it would take them an unfathomable 10 septillion years, that's a 1 followed by 25 zeros, to solve it. But Willow solved it in under 5 minutes. This wasn't just about speed, it was about proving the impossible. It demonstrated that quantum computers can solve problems that classical machines will never tackle. Scientists have a name for this pivotal moment when quantum systems outperform even the Google first claimed quantum supremacy in 2019 with a 50-qubit processor. Back then, Google stated that a problem that would take 10,000 years for a traditional computer to solve was completed by their chip in just 200 seconds. But this claim sparked debate. IBM argued that classical methods could solve the same problem in days. And while that debate continues, one thing is clear. Willow is on an entirely different level. With 105 qubits, Willow represents a massive leap forward. Each additional qubit doubles the processing power, making it exponentially more advanced than its predecessors. Beyond sheer power, Willow also addresses one of the biggest challenges in quantum computing: fragility. Quantum systems are so sensitive that even the smallest environmental disturbances can cause errors. But Willow incorporates advanced error-correcting techniques, stabilizing the system and making it far more reliable. By stabilizing Willow, Google hasn't just pushed the boundaries of quantum computing. They've taken us closer to a future where practical quantum systems could revolutionize cryptography, drug discovery, climate modeling, and beyond. This is where things get truly fascinating. Some experts believe that Willow's mind-bending capabilities might hint at the existence of parallel universes. This bold idea stems from a physics concept known as the multiverse hypothesis. Here's how it works. Quantum physics introduces the idea of superposition. the notion that particles can exist in multiple states at once. When measured, these particles seem to collapse into a single state. But what if something bigger is happening? Physicist David Deutsch proposed the many worlds interpretation, suggesting that every possible outcome of a quantum event occurs, but in its own parallel universe. Toss a coin in this world, it lands on heads, but in another universe, it lands on tails. Now consider quantum computing. The theory goes that Willow might not just be computing. It could be leveraging multiple realities simultaneously, with each reality contributing to its extraordinary results. Of course, this sounds like science fiction, and not everyone agrees. Some argue that quantum computers don't require parallel universes at all, relying instead on complex probabilities and the unique mechanics of quantum particles. Regardless of the explanation, Willow's performance has reignited debates about the true nature of reality. Are we witnessing a glimpse of the multiverse, or simply uncovering new layers of quantum mystery? Even as Willow's achievement seems groundbreaking, not everyone is convinced. Critics argue that its recent milestone was focused on solving a highly specific problem, one designed to showcase quantum capabilities, but with limited real-world applications. And then there's the question of scalability. While Willow's 105 qubits mark a remarkable leap forward, experts remind us that millions of reliable, error-free qubits will be necessary to build truly practical quantum computers. Even with Google's impressive advances in error correction, quantum systems remain fragile, prone to errors from the slightest environmental disturbances. But don't mistake skepticism for dismissal. Willow's skeptics aren't denying its importance. They're simply pointing out that we're still in the early chapters of this story. Because with every breakthrough, the dream of quantum computing comes closer to reality. A future where these machines could revolutionize fields like medicine development, climate modeling, and cryptography. So, while Willow may not yet be the quantum endgame, it's a vital step forward, paving the way for a world of infinite possibilities. Willow is not just a technological marvel, it's a glimpse into the future of what quantum computing could achieve. This cutting-edge technology has the potential to reshape our world, enabling breakthroughs in science and solving problems that are currently far beyond our reach. Whether or not Willow taps into parallel universes, its impact on computing and creativity is undeniable. But here's where things get truly astonishing. Scientists are beginning to speculate that Willow's capabilities might be the first evidence of how humanity could one day harness parallel realities for computing. Picture this: billions of iterations of this chip working together across countless realities, tackling challenges we haven't even begun to fathom. If this is just the beginning, what comes next could redefine the essence of humanity itself. We appreciate you coming along with us as we explore the frontiers of quantum computing. Please remember to like, share, and subscribe for more interesting videos about the future of AI. What do you think? Is this simply sophisticated mathematics at work? Or is Willow accessing alternate worlds? Share your thoughts in the comments below, and stay curious. See you in the next video.